Yeah, from Esri, there's many great temporal time examples in the community, but I'm going to focus on what I know, which is the stuff we're doing at Esri. So let's get started. So first off, if you have time data, the simplest way is just to map it. No need to jump to animation. Sometimes that simple map style it communicates what's important. Like this map here on the right, this shows before and after the Rotterdam Blitz. We're using above and below, diverging theme. Before and after that date of the Blitz. The areas in red, those buildings were constructed after the Blitz. The areas in blue before. This allows you to show how features within the map relate to a specific point in time. Or we could look at just the age of something. So the age of the response time for a fire incident from when the alarm happened to when they arrived. And the little fire station icons there, you can see, it makes sense, right? The closer you are to the fire station, the faster you can get there. Or the age of when the sewer line was installed. This is in Little Rock. And the thicker the line, that's how old it is. Some of these lines, sewer lines in Little Rock, are over 200 years old. Now we'll focus on animations, starting with animating imagery data. So this is Sentinel-2, land use, land cover. We're looking at change from year to year. This is, I would say, some of the early ways of doing animation on the web, where you take a whole image and you just create new images. It's actually very difficult to know what's happening, what's changing. Yes, you can see the river moving around, but in terms of the other details in the map, it's really quite difficult. These are also difficult to scale as tiled raster data, where you actually have the data pixels, is more prevalent. That can improve that. Then for the bulk of this talk, we're going to kind of focus on animating feature data. So animating via feature visibility. So each date value is represented as a row in your feature layer table. And you're only showing features within that time extent. And so this example here in Boise, that's going every 2 decades of how the city has grown over time. And you can show features either as a slice in time or cumulative, like this one does. This is a great example, actually, for the city of Denver. The purple lines are lead service lines in 2020, and the green ones, the green dots, are when those have been replaced and removed. So it's actually, within just 4 years, Denver's done a huge effort to reduce those lead service lines. And this animation communicates that. Sometimes you need to show time in the context of the story. So this is a 2018 Anchorage earthquake that was 7.1 magnitude, happened at 8:30 a.m. And that time's important, because if you go back to it, typically how you work with time, it shows you the time where you are. So if I'm in Pacific time zone, it's going to show me time here. But that's actually not useful for this. We need to be able to take that map and tie it to a specific time zone so it makes sense. This is another example of that. This is Michigan State University showing student activity. This is in the Eastern time zone, and it's showing hour by hour how alive the campus is. People start going to school, go to the clinic, and then as the day goes on, the clinic closes, and we start to see people going back to their dorms. If you didn't focus that on the Eastern time zone, it would be really hard to understand this map. I really like this one. This is an earthquake swarm in Ontario, California in 2019. Lasted about a month. In this case, we're showing slices of data. So the ones that are in full fidelity are what's within that time slider in the bottom left. But the ones behind it are the ones that happened in the past. This gives you that kind of like historical view of how this swarm happened. Don't worry, I think there was no more than like a 3.4 magnitude earthquake, but it was weird at the time, living close to that. Let's look at animating larger features. So this is trash debris requests for Aurora, Colorado, about 26,000 features. Once you start to get at that level of detail, looking at the raw individual features as they animate becomes not super useful. It's hard to tell the magnitude or the density of what's happening. So you can try different techniques. Like in the top right, we'll bin and show those individual features binning through time. Or the bottom left, we'll cluster it. Or the bottom right, a heat map. So trying these different aggregation techniques to let the density of that data can be a real powerful way to see how dense the data is through time. Where kind of animating based on feature visibility breaks down and what you can do about it. Now we start talking about larger data sets. This is an example of a 600,000 point feature layer of global temperature anomalies for the world. There's actually about 4,200 points. And this original data set, the way it came, each row was the year, and then we had the value. But the geometry is repeated. It's actually quite large to store this, 50 megabytes. And if we look at an animation of this, it's actually going to be pretty choppy. It's pretty hard. Even though this mapping library is completely on the GPU, actually doing that visibility and that transfer from your CPU to the GPU makes it not work very well. Well, you can use some techniques like pivoting the data. Let's turn each of those rows of years into columns on that table. So now we've got 4,300 points and 140 fields. Each field represents a year, and we've got that temperature anomaly. Now the storage is a lot smaller, just 3 megabytes. And if we look at this animation, no problem. Our Maps SDK for JavaScript works on the GPU. We put those points once on the GPU, and we have textures that represent each of the attributes, and we're just changing which textures we view. So you can create really fast interactive visualizations. Not to say that that way of navigating this is great, but just to get across the performance aspect of it. I don't want to give any PTSD, but if we look at COVID-19 cases, this is a data set of every county and every day from 2020. And so like this one column I've got highlighted here, that's April 17th. And this data set from Johns Hopkins was just the number of new cases that day for that county and the number of deaths. My colleague Christian, who's also here at NACIS, built this incredible application that allows you to explore this data. So remember, we just had raw counts, but he's using Arcade to compute the count per population. So we get more of a rate, and we can see how COVID grew that year, going from August into September. This was just a fascinating data set. It's a fascinating time to visualize what was going on. As we get closer to Thanksgiving, and then the cases start moving more to the south, quite fascinating. But since all that data is right there in that row, we can do things like Arcade expressions that look at the 1 month previous. So then we can do a diverging scheme through time. So where is it increasing, like in areas of brown, and where is it decreasing, that rate of COVID infections? Or even doing multivariate. So we'll draw the counts with size, but then we'll color it based on the doubling time. So a purple is a doubling time of every 7 days. A light gray is 60 days doubling time. And you can see, as we're animating through that data set, we have really high performance, it behaves well, and interesting patterns really just come out, and you can explore them. This one's slightly different. This is a data set that just, of all the buildings in New York City, we have like 600,000 buildings, and we just have one column, which is the date that it was built. But how can we animate that? Well, in this technique, we're going to change the renderer based on where the time slider is. So you get that turquoise for where the time slider currently is, and you get that fade away purple. This is also using like an effect like bloom to highlight those features. But all what we're really doing, if we zoom in on this legend here, is we're just changing the years that the colors apply to. Now, when we start talking about even bigger data sets, we need to go to other techniques, like videos. Earlier this year, Christian and I went to the NASA Goddard and visited the Scientific Visualization Studio, where they create many great visualizations. And their output actually is movies. So like this example here, which is showing ozone and how it's flowing on a day-by-day basis, hour by hour. They actually built this with the Discovery supercomputer. So they're crunching very large data sets into the nice high-resolution video. We can then bring that video into ArcGIS Online on the map, and I add the hillshade in the background. It doesn't quite come through, but with some of the other tools we have, like blending, we'll try out the multiply blend mode. Of course, with this dark color, that's not going to work very well. But we can use effects and do things like invert the color. So now the hillshade is going to pop through on that multiply, and we can use hue rotate to change back to the color blue. This is it's going to be a new feature that comes out in November in ArcGIS Online, but we're quite excited to bring a lot of those data sets from NASA in. And then over time, tying even the time slider playback to frames in the video. You can also do things like tracking observations as they move. This could be a vehicle or a person. It could be live, like you've got a sensor on you, or it could be historical. I'm going back and making sure that everybody visited every house in the disaster zone. With this kind of data, you have a lot of visualization techniques. You can have the latest observation, that would be like the big blue buses, or the big bus circles, and also the track color and the speed of the track color. We can also get more sophisticated and vary the size of those observations by the speed of the vehicle. The color can indicate how old those observations are, so this turquoise kind of fades away. And then the track color can sort of create data sets on the fly, like what's the average speed over this track. Now, visualizing data across time zones is the last thing I'd like to talk about. And time is very complicated. We at Esri have spent millions of dollars working on time problems. And it always takes a little bit to sort of get your head wrapped around it. So the traditional ways you would store like a date would have the date and the time. And then you store that data in a specific time zone. Maybe it's UTC, maybe it's your local time. But that becomes, that's only part of the problem, and it doesn't answer all of the questions. So what if you actually don't care about time? Well, actually, the date plus time can really get in the way. So there's a new field type called date only, where it just stores the date and you forget about the time. Or maybe you're just interested in the time alone. Just when is something open versus closed, and you don't care about the date. This last one is the most interesting, and that's date with time zone offset. That's where you're storing the date, the time, and the time zone where the data was collected. So in the US, there's a 6-hour difference between Honolulu and New York City. So 8 a.m. in Honolulu, it's 2 p.m. in New York. So if you wanted to look at things like what happened in the morning, well, actually, you can't do that with the normal date. You need to have that time zone in there. And this data type can help normalize that challenge. So if we look at this map here, it's kind of it's not the greatest map, I'll be honest, but it's a map showing fatal accidents in 2021 by morning, afternoon, evening, and night. And if we see it's just a unique type style renderer with an arcade expression that takes that date value and pulls out the hour. Now, since I'm pulling out the hour from this time data type with the offset, then I can do things like, hey, if it's less than 6 hours, it's night, 12 hours morning, and so on. And that allows you to do some pretty interesting visualizations. So here I can look across this data set by hour. So I'm clicking on each of those histogram bars, and I'm seeing when those occurred. And I see those on the map. Or let's focus on a per week basis. So if I look at Sunday and look at Sunday by hour across that entire data set, I can start to see some pretty interesting patterns. I see on Friday, more fatalities towards night, Saturday from night and into Sunday. So with that, takes questions. One question. Yeah, this one, so the question is, where do you set this? Well, this is a new data type that you need to actually store it that way. You can set that now within any feature service, and then that'll honor that within Pro or Map Viewer. But then there's also tools in your map where you can say, hey, actually I don't care about time zone. Just give it to me back and how it was stored. And that will help alleviate that problem as well. Cool. Thank you.